Good afternoon, everybody. I'm John Ramsey. I am the CISO, the Chief Information Security Officer for the National Student Clearinghouse. I'll be providing a presentation this afternoon on the security of blockchain and alerter data. I'm not going to go into a whole lot of technical details about blockchain. My goal this afternoon is to present some high-level concepts and examples so you can understand the benefits of blockchain and how NSC is exploring this technology in our efforts to better serve the education industry. For those of you not familiar with the Clearinghouse, we do a lot within the education industry. We provide services, and we really want to ensure that we use the best technology to provide the best services in order to secure learners' data and act on behalf of the institutions. Here's a reference of the service lines that are available for use. We do a lot with a lot of data, ensuring we can provide the best and most efficient services for the education industry itself. What is blockchain? The blockchain concept is actually fairly simple. It is a chain of blocks or data that continually grows over the life of the chain itself. For those unfamiliar with blockchain, one of the more pure definitions of blockchain is that it's a secure digital ledger of transactions. It allows students and institutions to maintain their academic records that can't be tampered with. And it continues to build on these records over time. Blockchain is really a technology that has the sole purpose of easing the process to share content across multiple parties in real time. So let's break this down a little bit. So what's a block? So think of a block in blockchain as a piece of data or an action. An example of a block might be that I was awarded a diploma. Or a block might be something as simple as employer C wishes to validate that I have a master's degree. That would constitute and create a block. So then what would a chain be? A chain is really all of this data in one place that's in chronological order. So think of blockchain like an accounting ledger. Every action is recorded. Once something happens, it can never be removed from the ledger. Or think of it like a checkbook. Every withdrawal or deposit is an action. You can't undo an action. So if I'm given $500, nobody can change the fact that I was given $500, and that could become block one. And if I decide to give away $200, you can't undo the fact that you gave away $200, and that really becomes block two. And that builds a transactional history of authoritative data over time. And blockchain is essentially that. It records every action and acts as a witness to all the transactions that's occurred since the initiation or creation of the blockchain itself on the individual or whatever is being recorded. So let's walk through a better example here of what I have. So let's look at block number one. Let's say John received a high school diploma in 1988. You can't undo the fact that I received a high school diploma, and it's coming from the high school itself as the authoritative source that I got it. Poof, that would be block number one. Block number two, I was awarded an associate's degree in 1992. You can't unaward the degree once it's provided. So that becomes an authoritative data point and is added to block number two. So block number one doesn't go away. It's just there historically. Block two is just added to that. Block three, I finished some classes in 1994 at University X. So these classes and grades get added into this blockchain. Block four, I took more classes in 1996 at University Y. I'm former military, so I have a lot of universities that I have attended to that helps formulate all of the requirements I had for my degrees. Going into block five, I was awarded a bachelor's degree in 1998 back at University of X. You can't unaward it, so it's there. And then going into block six, I was awarded a master's degree in 2003 at College Z. So you can see you have a lot of historical data over multiple places, all located now in one specific spot that can't be altered or changed. That's a pretty important concept. Data can't be altered. It's fed from authoritative sources. I might own the blockchain record. I can't manipulate the data that's on there because it's being provided by authoritative sources. However, with self-sovereign identity, I can identify who has access to my data and what data they have access to. An example there is entities can immediately verify degrees directly with students. So if I was applying for a position, that employer, through blockchain and my permission, could get the authoritative data of all of my information all at once. And I wouldn't have to go back to multiple schools to pull that for somebody. And that last bullet's important. We'll touch on that quite a few times. Data integrity is exceptionally high within the blockchain itself. Data can't be altered on the blockchain. It can only be added or appended to. So how does this work? Now we're going to go back to that example as far as that student receiving a master's degree. So there's a future employer who wants to know, did John receive a master's degree in 2003 from College Z? So the student has the authority to allow the future employer to validate this without going through a middleman. You don't have to go back to all of the schools. The schools have already provided the data as an authoritative data source, and I can let the employer know immediately if I have that degree or not. And again, this will go back into self-sovereign identity. We'll talk about this a little bit more, but this is really the student's data, but it's coming from authoritative sources. So right now, the employer makes a request, and that's going to be that first block there. The request is made. The very fact that an employer made a request also can create a block of transactional data on the blockchain. So not only do I have it that I've been awarded these degrees, I now know in 2021 that employer A wishes to validate my degree status. So that actually goes as part of a transactional piece of data, kind of like that checkbook example. Now that block that was just created about that request is now sent to every node in the blockchain network, or in this case, the education or learner credential blockchain network. And a node, that should be the next logical question. Then what's a node, John? Well, a node is basically a participant that's on the blockchain. And I'll use Bitcoin as an example. We've all probably heard the press on Bitcoin and how people are making tens and hundreds of thousands of dollars on Bitcoin. And they talk about miners. Well, each of these nodes is a participant, and each of these miners, and that's a node, is a miner. They actually help process these requests. So we have the employer that made the request, does John have a master's degree from College Z from 2003? And all of these nodes, all of these miners start processing this request. And they have some pretty complex calculations that they use in order to get the correct answer if John does or does not have that degree. And it's done with a high level of accuracy because of the complexity of the calculations being correct if he did have it. So now you have thousands of nodes are competing to be the first one to process this request. And the first one that gets it done gets a reward. And this is where you hear about all of these miners making a whole bunch of money, and they've got all of these PCs and computing power trying to be the first ones to do this and make a little bit of extra dough. This is it. They often get some sort of financial incentive for providing enough power and distributed power throughout the blockchain network to help process these requests. So in this case, we're going to say that the blockchain came back and through all of the mathematical calculations, identified and analyzed the nodes and the blocks that John does have that degree. The very fact that that transaction was fulfilled gets added to the blockchain. It is sent to all the nodes on the network, so it's distributed everywhere for future use, and the transaction is done. To the user and to the employer, it's fairly simple. Do I have it? The blockchain comes back and says yes or no, or when it's awarded. So then goes into what type of use cases do we have? So imagine a future where every individual has self-sovereignty over their verified identity, education, employment data. John can identify who can access my data, what data, and when they can access it. Now imagine the students, John is empowered to seamlessly share that data to build and advance my career instantly. I don't have to go back to 8 different institutions or 4 different credentialing bodies to show that I have all these different certifications and degrees because I'm trying to get a job with the right employment entity. So with these use cases, there's one where you got accreditors, validators, and testers. Let's say testing for a credential. In order to test for a credential, you have to show that you have 5 years of experience that's been certified someplace. And I've got to be able to show these prerequisites to take the test. I could provide my digital wallet as a student to the tester, and the tester can validate immediately, yes, John meets the requirements, go ahead and allow him or her to test for the certification. Or employers. The employer indicates that they want a master's degree or they want a nursing certificate, some sort of a requirement for the position. They don't necessarily need to pull all the transcripts from all the schools that the learner went to. They need something that's unaltered data, that's authoritative, that says, yes, the student does have this nursing certificate in order to apply and be considered for this position. The learner simply provides their wallet to the employer. The employer can immediately validate if the learner qualifies for the position. From a student perspective, I'm former military. Over my military career, I attended 10 different schools. I have an arts transcript of my military service. I have 7 security certifications. I've got 2 degrees from 2 different institutions. Historically, every time I moved from assignment to assignment, I had to get all the data from all of those entities to whatever the latest school was that was certified to provide services on the military base in order to continue to progress my educational desires. That's a lot of work. Now imagine all I have to do is provide the latest school that I attend on my wallet, and they got all my data to the new school instantly. And then teachers, similarly, they can validate immediately if a student has the correct classes and prerequisites in place. There's a lot of potential use cases. But what we're here for is really to talk, how is blockchain secure? And this is really the core of the conversation, but there's some concepts with blockchain that's really important. Blockchain is really a system of recording information in a way that makes it darn near impossible, exceptionally difficult to change, hack, or cheat the system. It really counters data tampering because of how it tracks and stores data. If you make the change to the information record in one particular block of a blockchain, you can never rewrite it. It's always there. You can't go back and change anything. You really append to that data. You can't rewrite history. It goes back to, once I'm given $500, no matter what I do with that $500, you can't change the fact that somebody gave me $500. And all of this is always tracked at some sort of date and timestamp of the change itself. So let's talk about some of these high-level concepts. The first and foremost, if you hear blockchain, it's almost impossible not to hear the phrase immutability. And that is a very fancy way of saying validated records can't be changed. Nothing gets rewritten. The data can't be altered by the student or the institution or the employer. Once it's there, it's there. The only thing that can happen is the data gets added to. So with this said, learners can't go in and alter the data that was provided to them by schools. Employers can't alter any data as far as employment history if that was on part of the blockchain. It can only show when items or transactions occurred and when they changed. Encrypted. Every record is encrypted and hashed. And the way of thinking of this is like a digital fingerprint. Everybody's fingerprint's unique. So every time you do a hash, that's really getting a digital fingerprint of every time something is added. And every time something is added, you get a new fingerprint because you have a change in what you're looking at. And no 2 fingerprints or hashes are the same. It's really like digital DNA. What is you is you. Nobody can really fake that and alter that in any way. And if data gets tampered, the reality is the fingerprint changes and the fingerprint no longer matches to who you were to who it's showing who you are now. And then typically the request isn't processed. So that's a really important concept, along with the fact that the records can't be altered. It's hashed every time. So if for some reason something got altered, although you can't do that, it's going to reflect that as a quality control check as well. And then there's a very detailed concept called proof of work. And proof of work, in the absolute simplistic way of defining this, forces the slowdown of the building blocks in the blockchain. Proof of work is a concept that requires a people who owns all of these computers in the blockchain network, all of these nodes, they have to solve an exceptionally complex mathematical problem in order to add something to the block or to the chain or to fulfill a transaction. A lot of times this is called mining, and miners are usually rewarded for their work. But the proof of work means there's a heck of a level of effort that has to happen in order for this to get added to the blockchain and to be validated. And the mathematical problem that they use, it's solved by trial and error. And the odds of solving the problem are about 1 in 5.9 trillion. You have a better chance of winning the Powerball several times in your lifetime versus unintentionally solving a blockchain transaction. The Powerball odds are 1 in 300 million. You could win the Powerball 19,000 times before somebody would be able to crack the algorithms that are used within the blockchain environment. That makes the tampering exceptionally time-consuming, up to years, if somebody was actually going to try to tamper with the blockchain solution itself. And with that said, the next concept is called distribution. It's a distributed network. There's multiple nodes. All of these nodes contain the data from the blockchain. So they've all got to be compromised. Or let me rephrase that. Most of us are used to information being stored in one centralized database with the company. And when you hear about these data breaches that are out there, the data breach usually involves one database that had all the information. Well, with blockchain, that's not the case. There's not one database with all the information. All of the data is distributed across all of these nodes within the blockchain environment. Every node also then validates whatever is appended to the blockchain is authentic. It's just not one node saying, hey, that's good, we're going to add on to it. All the nodes validate and add that data. Because it's going across every node and every network participant, there's transparency. Everybody's got a copy of this ledger, of this checkbook. One node can't hide or compromise or alter data without all the nodes agreeing that the data transaction is authentic. And then lastly, identities are anonymous. You can do this, but you don't have to reveal who you are, so you get to maintain that privacy.
We had a question pop up.
Okay.
In the event that there is an error in a student's record that's not caught before the validation, for example, a student contacts and disputes a grade at a previous institution and wins that dispute, what would happen on the blockchain in this scenario?
Good example. So what would happen after the institution would validate that maybe the dispute's authentic and the information is incorrect? And the institution, when they go to update their data as an authoritative data source, they would have an update that would affect the student. So it wouldn't go back and change what that error was, but what it would show as of today's date and time, the institution identified that it's an issue and updated the record so it reflects what the current status should be. Or in this case, if the dispute was incorrect, then the institution wouldn't have to take any action and it will remain as it is. And the benefits of blockchain and the clearinghouse. So there's two concepts here that I'm going to echo over and over again. If you leave away with anything, this is a slide. Self-sovereign identity and wallet, because this is what you're going to be probably associated with if you ever go down the blockchain route. It's important to note again and again, learners can't change their data. They control who they allow access to their data because it's their data, but the data can't be altered. It can only be appended. My blockchain data indicates I've got a master's degree in computer science. I have no access to go in there and change to show that I have a master's degree in law or I've got an MBA. The data is provided by an authoritative source like an institution, and it's appended to the learner's blockchain record. Another example is if I get a D in chemistry, you can't undo that. I've got a D in chemistry. I can't go in as a student and alter or reflect that. Now, in this case, with the question, if it was disputed, let's say my D was supposed to be a B and somebody fat-fingered and put in the wrong grade. Now, what will happen, the school can append the data to reflect the new grade, but that's about it. You can't go back and change anything. It just will reflect what the current status should be. Now, if an employer had a request, hey, what's all the grades that John ever had in chemistry? Now, there's a concept called a smart contract, and how the blockchain is built. It knows to go in and look to get the latest information to ensure that it is the correct data that's being provided to the employer. So the two concepts that we have here, the self-sovereign identity and the wallet. We'll touch on the self-sovereign identity first. And the whole concept is simply the student owns their data and who can access their data via the blockchain. NSC is a secure central repository of authoritative data provided by the schools. We have a lot of data on a lot of people. But, and this is some of the core reasons why we're taking a key role in the blockchain discussions. How is that data accessed? So let's talk accessibility. We just mentioned there's a lot of data on a lot of people. With self-sovereign identity, the learner, the owner of the data, controls who can access what data elements and by whom. And a good example is if an employer wanted to see if I had a security or a nursing credential, when I provide that access to the employer to validate that, I can indicate the employer can only access my validated credentials. They don't get full access to my transcripts and my schools and my histories unless I, as the owner of that record in the wallet, allows that access. The employer can only verify the credential request. So the student has granularity in what and who can touch what and access what. So going into there, we have the second concept, wallet. And the question that should come out is, well, heck, John, how does this really work? We've had 4 slides of concepts. How do we actually practice this? And in a very simplistic way, visualize this. You've got a mobile phone. and there's an app on the phone, and the app on the phone might be called Learner Credential Wallet. And I'm going up to an employer and I'm applying for a position. The employer is also signed up on the blockchain. The student opens up the app and reveals a QR code, and that QR code gets scanned by the employer gets the information. Conceptually, it's that simple, but it's important to note, what is the wallet? And the wallet is really the private key and the data elements that the student has and controls access to. It's kind of like a lock to your house. You've got the key to your house, but that wallet is really the private key to your data, and you can control who can go in and out of your house as you choose. So why is this important? And I don't think I could state it any better than our CEO, Rick Torres, as well as our VP for Business Solutions, Larry Hatch, indicated here. And Rick mentions, all learners deserve a way to translate their full education, training, and work experience to a record of transferable skills that will open the door to high-wage occupations and careers. Technology is upon us. A blockchain is considered what they call a disruptive technology. It's here. It's not going anywhere. And the Clearinghouse wants to make sure that we're helping facilitate the use of that where it makes sense. Rick's second quote there, as we proceed, the Clearinghouse will be involved in multiple conversations across various blockchain initiatives to sort out how we can perform an industry-wide function serving institutions, learners, and entities as part of our mission. And the reality is, we're trusted agents of your data. We're making sure that whatever technologies are used, it is secured, that we've got the privacy considerations in place, the legal considerations in place, the security considerations in place. We want to make sure that our platforms and portfolios are designed to really support whatever the various environments might be. Part of the Clearinghouse's mission of the service to the education workforce communities is directly linked to supporting the development of the most appropriate use cases of technology. And then Larry mentions about the self-sovereign identity. It's here. It's going to be here to stay. There's an incredible amount of data about all of us out there in the digital ecosystem. The theory and theme around self-sovereign identity, and you hear it more and more in the press all the time in the news. The individual owns his data or her data, regardless of the technologies that's being used by. And with that said, the Clearinghouse and the consortium of leading academic and professional organizations, we're all working with IBM. We have been for about the past year and a half. We've been consistently and continually evaluating the use of blockchain technology to make sure that we got a permanent and verifiable record of learning skills and credentials and certifications. And doing a quick synopsis, it's an exceptionally secure way to share skills and credentials. Think immutability. The data can't be altered. The odds of winning the Powerball are better than altering the data. That is an unbelievably huge statistic that accounts and attributes towards the security of the data itself. NSC is here to help guide us all through the waters. You're not alone as blockchain's upon us, and it's not going anywhere. As we're looking at this and we're working on the Learner Credential Network, we want to make sure that everybody understands we're also looking at all the legal, privacy, and security issues that go with it. We're here to serve you. We will through blockchain as well, ensuring that the post-secondary industry isn't left behind by no means. And without a doubt, we understand the integrity of the education record is critical. We know that integrity and the ability of somebody to alter that is of paramount importance. And that's the beauty of blockchain. It can't be changed. It's only coming from the authoritative data sources. And that's the key thing. Students won't have access to it to change the data, only to allow access to people to see the data. Then the last bullet there, the Clearinghouse will definitely make sure that we remain vigilant for student privacy. We're committed to FERPA, as well as students' privacy rights, the Higher Education Act, all applicable laws. Blockchain is new to everybody, but it's getting to that point, it's not that new anymore, and we want to make sure that when the education industry is ready, that we're helping to facilitate that. The core things about blockchain to remember, once it's on the blockchain, the likelihood of compromise or integrity issues of the data is unbelievably low, which is great. And keep in mind, that mathematical problem to solve the blockchain transaction is 1 in 5.9 trillion. So with that said, that concludes today's presentation. Pending any questions.
We do have one additional question. There is movement from proof of work to proof of stake. Is there potential room in the future to move into proof of stake?
We have a technician on the call. So the concepts between proof of work and proof of stake is a second concept with blockchain as well. And they're both ways on how the blockchains can assess and conduct transactions and the validity of the transactions. I think as we explore the technologies, the clearinghouse will pursue and recommend whatever makes sense to the highest level of security for the learner data for the institutions. I wouldn't say that proof of stake is not out of the picture, and I wouldn't necessarily say proof of work is dominating the picture either. It's going to be whatever the best solution is between the two. And so with that said, being completely transparent, proof of stake helps eliminate and minimize one type of blockchain attack out there called the 51% attack. If somebody out of these thousands and thousands and thousands of nodes in a blockchain actually owned 51%, under one of those concepts, they might have the ability to reduce the security of the blockchain itself. But the likelihood of that happening is so unbelievably low, proof of stake helps to counter that in case that were there. So blockchain is evolving just like any other technology that's out there. To answer your question directly, proof of stake is not out of the picture. It's going to be whatever the best solution is and most secure solution is for the student data, learner data.
Thank you, John. Thank you all for joining us today. And John, if they have any further questions about cybersecurity or anything related to that, how can they reach out to you?
Yep, the last slide here, jramsey@studentclearinghouse.org. Please don't hesitate to ask any questions. At the Clearinghouse, we are an open book. We will provide advice, guidance. If you wish to know how something is more secure or how we secure your data, I am happy to have one-on-one conversations or one-on-group conversations. We are here to serve you.